Go Language Programming, Chapter 4, Unit 5. In this unit, we will cover linked list data structure, using new function to create linked list, create linked list using methods. So a linked list is a linear data structure in which elements are not stored at contiguous memory locations. So that's a major difference between an array and a linked list. In array, the elements are in contiguous. So when you have a linked list, they are not contiguous. So the elements in a linked list are linked using the pointers. So basically, each element points to another element, no matter where in the memory it is located. It will know the address of that other element, and that's how it creates a linked list. So in simple words, a linked list consists of nodes where each node contains a data field and a pointer to the next node in the list. So basically, element is nothing but considered as a node. Okay, and then the node could have, of course, multiple fields, multiple data fields, but it could have multiple pointer fields as well. But usually, the linked list comes into like a doubly linked list or singly linked list. So in the singly linked list, there will be only one pointer in the node. In doubly linked list, there will be two pointers in the node. One pointer will be pointing to the next element or the next node, and other pointer could be pointing to the previous node. Okay, so that's why it is called a doubly linked list. So depending upon what kind of application that you are planning to write, you have a choice to either use a doubly linked list or a singly linked list. Okay, so let's look at how this all works. So data structures and algorithms are bread and butter of computer science. Without that, basically, lots of good software would not be able. We would not be able to create the software. So that's why any algorithms or the data structures are bread and butter for writing any good software. Linked lists are one of the simpler data structure. So in fact, linked list is the simplest data structure. There are other data structure, like tree data structure. In that also they have a concept of nodes, right node and the left node, and so forth. So that gets more complicated. Okay, but here we're going to concentrate on the linked list. So a linked list is a linear collection. So it is, since it's a list, it is just linear, like a list of data elements. So each node will have the data in it with the pointer to point to the next node, in which linear order is not given by their physical placement in the memory, because each node, as I said earlier, could be sitting in different locations in the memory. The only way the node can find is because each node has a pointer field, and that node would be pointing to the next node, and that's how the linked list is created. So a linear data structure is the one where its element form a sequence of some sort. So it has some sort of a sequence, even though they are scattered around in the memory. So in linked list, each element points to the next element, like we just talked about it. It is a data structure consisting of groups of nodes which together represent a sequence. So basically, the group of nodes are put together, and that's how the sequence is created between the nodes. Each node is composed of data and a pointer, okay, that holds the address of the next node in the sequence. And we already discussed that. So basically, if I have to draw this, the linked list, it will go like this, okay, and this will have a data, and then this will be some sort of a pointer. So this will be next. Usually they call it a next, and it will be pointing to. So this node, first node, probably got created at address 1000, and then the next node got created at address 2000. So this next would be holding the address 2000 right here. So 2000 would go in here, and then the third node would be at address 3000, and then the fourth node would be at address 4000. Okay, so now this node right here would be holding the address 3000, and then this node would be holding the address 4000. Okay, that's how it is pointing to here, and this is pointing to here, and this would be a data. Okay, data could be not only one field, it could have many fields in there. So that's how the linked list looks like. Data. And then the last node, if the linked list only has 4 nodes, then it will be pointing to a nil. Okay, so it would not be pointing to anything. It will have a nil in there. So that's your linked list, and this kind of a linked list can be, created many different ways. In next slide, I try to explain the easiest way that any person who has never had any experience with a linked list. So let's see if I can explain it, how the linked lists are created. So this is the simplest way. This in real life, you really would not be creating a linked list like this, because in this example, basically, I am creating each node manually and then linking it manually. In the real life, you would not really do that. So the only reason I'm doing this way is so a student who have not have any experience with the linked list, they could easily understand. Okay, so let's see how we will create a linked list. So as we in the previous lecture or previous chapter 3, we actually covered the new function. Okay, and we discussed that the new function, which is a built-in function in the Go language, it allocates the memory, for the given type. The type is the one which takes as a parameter to itself. Okay, so that is the type of memory that it will be created by using a new. Now, what once it creates the memory, what it does, it initializes to 0. Okay, so basically that's why it is called zeroed memory. So everything within that piece of memory will be 0, and it will be of some type. Now, after it allocates the storage, it returns the address of that memory. Okay, and assigns. So of course, you if you choose not to assign it, that's a different story. But once you use, like, you say new, okay, and int, it will allocate the one piece of memory, okay, which only this piece of memory only can store the integers. That's all, because we said so, because we tell the uh, new operator, this is new, okay. So we tell the new function to allocate the integer type memory. So once it allocated it, it will allocate at some address, let's say it allocated at some address. Now what you can do is you can save, this memory to some variable. So if we use a short declaration operator, this variable will automatically will become pointer type, okay. So that means that pointer type variable memory will be created, and this address will be saved in here. So this is pointing to here, okay. Now we can store anything that we want. So if we want to store something on P, then we can just say like 100, so value 100. So then we are dereferencing it and putting 100 in there. It will be stored right here, okay, because the P is pointing to this piece of memory. So that's what the new operator does. So we use the new, or I should say, new function, because in C++ they call a new operator, not the function. In Go language they call a new function, okay, to allocate the memory from the heap. So another thing that we discussed in last chapter is that new always allocates the memory from the heap, okay. So that's one other thing to remember. So now, basically, new function allocates to create each node. So in our case, instead of allocating the memory for integer, we will allocate the memory for the user defined data type, which is the node. Okay, that's what we're going to do it in this example. So each node that is linked to the next node to create. So that's why we allocate the memory for the node. So the new function always allocates memory for each node from the heap, okay? So that's what the new function does, always allocates the memory from the heap. So now let's look at this example 4-14. We start the example with the package main, import the FMT package for using the print function, okay, from that package. And then at starting line number 4, we are actually creating a user defined data type, in this case, which is node, okay. And in here we are actually saying that I want to allocate or I want to create a template which will have the two items in there, or two fields. One will be of integer type. The other one, which is at line number 6, is going to be of type node itself. Okay, but in this case, as you can see right here, it is star in there. That means this variable next will only hold the address. That's what it means. Next can only hold the addresses. That's all. Okay. So when we do the new, okay, right here at line number 13, I will get one node created. Okay, so one node is created at line number 13. Okay, of this type, node type. So node type has two members, two fields in there. So basically, it is going to be creating it, and it will be created at some address location 1000. So I'm just picking 1000 address, because every node that we create, it has to be in the memory, some location. Okay. Now I can use this new operator, and as I told you, the new operator will allocate this memory from the heap. I could have done this, what you see it, and I commented it out at line number 10. Okay, I could have used this n% in front of the node, and of course initialize the data at the same time and created the node. Okay, then it is up to compiler. It could have taken the memory from the heap, or it could have taken the memory from the stack. Okay, so that's the behavior of the Go compiler. Okay, Go compiler chooses to take the memory from either from the heap or from the stack. So, but if you just use a new operator, it will always take the memory from the heap. Okay, so in this case, the memory will be allocated and initialized at line number 10. At line number 11, also memory will be allocated, okay, and nothing will be initialized. So when I say nothing, actually the first field compiler's job is to initialize automatically. Even in here, I'm putting it nil. If I wouldn't have put the nil, it still will nil it out. That's what the compiler, Go compiler, does, automatically initializes it. Okay, so in this case, instead of a 1, it would have initialized to 0, the value, and the pointer will be initialized to nil. Okay, so but I'm not using this this way to create the nodes. Okay, but I'm using a new. So now in this case, I have a current pointer, okay, a tail pointer, a head pointer. Okay, so these are the pointers. So these are pointers. That means they will be basically will be holding the addresses. So this is a current pointer. This is a uh, tail pointer, and then this is the head pointer right here. Okay, so in this case, when I created the first node, the current pointer got the address 1000. Now notice that this is just a pointer. Okay, the pointer variable that will be of this type, that can point or hold the address. So the pointer variables always just hold the address. So we are using a short declaration to initialize the address to this current pointer or current PTR, because the new will be returning the address. So the address will go in there. So that now this pointer is pointing to right here, this first node. Okay, and then when in this line number 14, I'm saying, okay, whatever the current pointer, whatever the address current pointer is holding, just copy that address into this tail. Okay, so that's what it is going to do at line number 14. And then line number 15, the same thing. I'm copying the address to the head. Okay, so all three are pointing to right here, the first node. Now, once that is done, then at line number 16, then what I'm saying, that go to the current pointer, go to the data portion of the current pointer, which is this one, and initialize that with integer 1. Okay, so I put one in there. And then at line number 17, I'm saying go to the current pointer, dot next, so this part, and do the nil. I if I want, I don't have to do this line, because as we just talked about, whenever the memory is allocated, compiler automatically initializes everything to nil. So this will be a nil, and this would have been 0, but I had to put the data in there, so that's why I put 1. But in my case, I'm just saying that I want to do it myself, so I put nil in here, so it is not pointing to any next node. Now, starting at line number 19, I'm saying that go to the tail pointer, which is this one, go to the next part, the next field, which is this guy right here, okay, and create another node. So I create another node, okay, right here, this node. And so this node, let's say it was created at 2000, and pick up that address and write it to right here, which will be 2000 will be written right here. Okay, so now this node is pointing to here. Okay? So that's what the connection will happen. And then of course when we created a new node, it also has the two part to it. Okay, and then I could have done it this way if I wanted to, but again I would not have known if the node would be in the heap or in the stack, on the stack. Okay, so that's why I'm using a new. So doing this and this is almost the same thing. And then I am saying that pick up the address which is in the tail dot next. So tail dot next address, which is 2000. Okay, so pick up that address and initialize that to the current. Okay, so initialize that to the current pointer. So this will become 2000. Okay, so now it is no longer pointing to. So let me see if I can erase that. So it's no longer pointing to this. Okay, and it is pointing to right here. Okay, and basically the current is pointing to the newly created node, and then I'm using the current dot data, so I'm putting 2 in here. Okay, and then I'm saying that the make this nil, so this one, maybe I just go and clean this up a little bit too. And this is pointing to 2000. Okay, so basically we initialize that and then make this one a nil. Okay, this one a nil, and uh, and then we're saying move the tail. Right here at line number 24 we are saying move the tail. So tail right now is pointing to the first node. So we are saying that put the address whatever the address is in the current. So basically to do that I will just remove this number. Oops. So now tail would be pointing to 2000. Okay, and that means it would not be pointing to this. So let's move this out, and now the tail is pointing to this node right here. Okay, so that means we created the this second node. Now the third node we do the same thing. We create one more node right here. Okay, and this node will have the two parts to it. One is the data. Okay, so very first thing that we do is to create a node. The node will be created at some address 3000 or so, and then we pick up that address, put it into the tail, go to the tail, and go to the next part, which is this one. Write this address to here. So instead of a nil, so it would not be pointing to the nil anymore. Okay, it will be actually pointing to the newly created node. So we put 3000 in here. Now we know that it is pointing to here. Okay, so that's what we did, and then we are saying that move the current pointer. Okay, so we are saying that go to the tail dot next, wherever the tail dot next is this one 3000. So we are saying pick up this 3000, which is the newly created node, and put it into here. So basically instead of a 2, it will be 3 right here, and it would not be pointing to this node anymore, and it will be pointing to the newly created node. So I'm just going to come from here and point it right here. Okay, so it's pointing to that node, and of course this will have, now we are using the current dot data and assigning 3 to this. This is the current dot data, and then the next one, this will be a nil. So this will be a nil. Okay, and then we are saying that move the tail. This one is moving. So what we are saying that current, whatever the address the current is holding, in this case the current is holding 3000, so put the same address in the tail. So we go and pick up the razor, and then we put 3000 in here. Okay, so then that means it is no longer pointing to here, and it is going to be pointing to this newly created node. Okay, the tail is pointing to the newly created node. Now let's continue this same linked list in the next slide. So in the next slide, what we are doing is we are going, so we have 3 nodes in the linked list, just now that we created 3 nodes. Okay, so 1000, 2000, and 3000. Okay, and then so this will be pointing to next node. Okay, and this will be pointing to 3000, and this is pointing to nil. Okay, and then this will have 1, 2, and 3. Okay, and then the head pointer that we had it in the previous case, it is never moved. This is head. Okay, that will be holding the address 1000, so it's pointing to here. And the tail, which is keep moving, so we have the tail right here. Okay, and tail is pointing to the 3000. Okay, so it is pointing to right here. And the current basically in the previous slide that we saw, this was the current. So current is also have the same address, because that's the current address. So it is also pointing to here. But now what we are doing at this line number 33, we are saying, okay, get the address of this current, same address as where the head is pointing. So we are basically changing the address. So we, instead of a 3000, what we will have is 1000 here. Okay, so that means this is no longer going to be pointing to here, it is going to be pointing to the head. So this is going to be pointing to here. Okay, now within the for loop, the first thing that I do is to check current not equals to nil. Okay, so nil is going to hit, that means it's going to hit this guy, so then it will stop. But as long as it is not going to, current will not have the nil, so that means this address, instead of a in some address in there, it will actually will have a nil in here. Okay, if it goes through traverse the linked list, so then that's how this for loop will stop. Okay, so as long as it's not a nil, current is not a nil, then what we are doing is we are saying that, okay, create one more pointer, okay, which we call it a delete this node. Okay, that's the delete this node pointer. So in this case, what we are doing, we are copying the address, whatever the address the current has, into this one. Okay, so it is also pointing to the same first node. Now, once we do that, then we are, we are in the print line. We are saying that, okay, I want to print the data before actually I delete something. So I want to make sure that my data doesn't get lost. Okay, so I'm using a current dot data. So current dot data is this one right here. So it will print that. Okay, and then at line number 37, I'm saying that, okay, print the address of the delete, or the print the um, yeah, print the address of the delete this node. So that's what it is going to do. So this is the address of the delete this node. Okay, and then this is the address, of the current node right here. Okay, and then I'm saying at line number 38, I'm saying that wherever this current pointer is pointing to, go to that and go to the next part of it. Okay, next part, next thing, which is to 2000, and write this back to the current. So instead of a 1000, now this will become 2000. Okay, so basically this will become 2000. So now this current is no longer pointing uh, to the first node. Okay, it is now pointing to this second node right here. Okay, so current is pointing to that. So so now when I go and at line number 39, I'm saying that delete this node. So I'm printing the address of the node again. Delete this node. Okay, so delete this node is the same as before, which is right here. They both are the same. And then I'm saying that the second node. So this is the data from the second node, and then this is the address of the second node. So that's where that's where this is pointing to. So this is an address of the second node. This guy, even though I have 2000, but in real memory, that when I was running this program, this the address it was. Okay, and then I am using at line number 41. I'm saying make this delete this node a nil. So basically, this guy is not pointing to anything. So I'm removing the address. So that means this is no longer going to be pointing to any place, and this will be a nil. This will be a nil. So it's not pointing to any place. And then once I do that, and then do the printing again, right here, okay, that's why it is printing this nil right here. Okay, and then this is the address of the current node itself. Okay, and then it is printing the data from that node. And then in the uh, next line right here, then it goes back up again. Okay, in the second loop, and then it will do the same thing until the last node. When it comes to here, this 2000, instead of a 2000, it will be nil, and then it will stop. It will come out of the for loop, and it will come to here, this line, and it will print. So it will print this current, and then this is the current pointer will be nil. Okay, and then this head pointer will will have something in there. So that's what head pointer, because head pointer is still will be pointing to the first node. The memory is still there. The garbage collector has not really collected the memory. And then the tail, okay, the tail is going to be the last node, and the data for the tail will be there as well, So the garbage collector will come and collect it as soon as all this memory will be collected by the garbage collector in Go language, and basically as soon as the program stops. Okay, so that's how this singly linked list, which is basically is that code is done in such a way that the new person who wants to know how the linked list works, that's why this simple way to explain. But in real life, or even in your assignments, you would not really use this way. Okay, so this is in the next example. That's the way that you really should create the linked list. Okay, so let's look at this, how in the real life that the linked lists are created. So create the linked list using a method. So we will use a method, and that method will create the whole linked list for us. Okay, not one node at a time. It will just the for loop is the one which will create the whole linked list. So in this case, we have the data structure called node. Okay, with the two fields in there. One is a integer type field data, and then the other one next is a pointer type. And then in that case, this is the user defined data type called node. And in here, basically, we have another struct which is which the name is a list. Okay, and in this case, the head node. So this head node is the same kind of a node as in the previous example. This will hold the head of the list. The head node address of the head of the list. Okay, that's why it is called the head. So now let's go and see how this method is written for creating this linked list. So the method name is append. It takes one parameter of type pointer, okay, and then it has the receiver. So receiver is of type pointer as well, but it is of type list, okay. So that's and then the parameter is of type node. So that's the difference. So now within the body, very first thing we do is we check if this in the receiver, which has a parameter which is of type list. The variable is l dot head. So we are accessing this member from the list, and we are saying if it is nil, so initially it will be nil. So when it is nil, we are saying, okay, assign the node that was passed to it, because the node was created within the main body. Okay, and the address of that node was passed right here. So we are saying that assign that whatever the address of that node is holding. So the first address of the node will be assigned to the head. Okay, so and then return. So that will happen the very first time. Okay, and then it will return back to the caller, which is main. And then when this method is called again, then the head is not going to be nil. So it's not going to come into this part. Okay, when this method is called again. So in this second time when it comes in, then it creates a current node pointer. Okay, and picks up the head, whatever the head is holding. So basically, in this case, I will start drawing it in the in the main when we go into the main, and then what it will do, it will check if the next is nil. not nil, then if it is not nil, then node dot next, whatever is in the node next, node dot next is move to the next node in the list, okay, and assign that to it. And then when it comes out of it, the last node, so then it will have, it will put the new node in there. So now let's go to the next slide and see how this is done in the main. So in the main, basically what we have is um, this list data structure. And as you saw in the list data structure, there is only one field, which is called head. Okay. And that field is just basically of type node. Okay. So that field is of type node. So um, uh, um, when we do that, this head will be created, okay, right here. And so this is a head pointer. And then basically we are using the uh, the variable um, L to call to append. Okay, append is a function which is which we just went over, right here, append, and it is taking the one node. Okay, so in here, what we are doing is we are creating a node at a time. So as you can see, this is an n%. So that means after it allocates the memory, so this is one node created. Okay, so node is created, the memory or the data is allocated, I mean data is initialized to that node, and then the, that's all. It doesn't initialize the second part, so this will be nil for the first one automatically, okay, because Go compiler puts everything to nil. And this, again, I will just start with the 1000. So it was created at 1000. So what we are doing here is we are saying that, okay, this node was created at address 1000, okay, and passing that address to the append function, okay. And append function, when we go and see in the append function, basically, we check if this is nil. The first time the head is nil, so this was 1000 first time. So the address of this new node will be assigned to the head. So that's why this will be holding 1000. So it is going to be pointing to right here. Okay. And then within that, right here, um, once it does that, assign the address to the head node, then it returns back, because of this return statement, it will go back to the main. Okay, it's not going to come to line number 23. So in the main, basically, it goes and creates another node. Okay, so another node will be created. So now this time, this node, when it is created, and append function is called, and this node is created at 2000. So, and then the data is assigned to 20. Okay, and then in the append function, this is sorry, append function will basically not it's not going to go in this piece of logic, because head is not nil. Head is, as you can see, head is pointing to 1000, the first node. So it's not going to be nil. So it's not going to go into this logic. So it's going to come here. So then it is going to pick up the address, whatever the head is pointing to. Okay, so if I go back to here, it will create this pointer name current node. Okay, so current node will be created, one more pointer. Okay, and it will, what it will do, it will copy this. That's what it is doing. It is copying uh, it is copying whatever is in the head is, okay, to that. So whatever, wherever the head is pointing to is going to be copied here. So current node is going to be pointing to this node as well. And then once that is done, let's go back to the pen again, and then it is going to go and check current dot next not equals to nil. Well, in this case, if you go and see current dot next, current dot next is nil. So that means it's not going to go in this logic, and it will come to right here. So what it will do is to newly created node basically will the address of that node will go into the next part of wherever the current is pointing to, and this will go in here. So this will be pointing to 2000. Okay, so now this link is created, and then once that is all done, then it comes so then this append will go back to the caller. Okay, it's a caller, and in the caller now it is at this line, at line number 34. It will create one more node, okay, right here, and let's say this is 3000, and in this case, again, the same thing. It will basically go back to the to the append function, and in that append function, now it's not going to go in here, and this L dot head, whatever the L dot head is pointing to, so L dot head is pointing to 1000. That will be basically assigned to current node. So in this case, we already went there. So now this well, head dot next. So we're talking about head dot next. Head dot next is assigning to the current node. So basically, in this case, it is going to go and check if the head dot next is not null. I mean, current node dot next is not nil, so it is not nil. So what it is going to do, it is going to go and get wherever the current dot next is. The current dot next is 2000. So it will pick up this address, put it in here. This will become 2000, and that means this is no longer pointing to here, and it is going to be pointing to here now. Okay, and then the data or actually then it is going to go back to here, and then check if that is if that is not nil. Well, in this case it's going to be nil, so the newly created node address will be assigned to the to this guy right here. Okay, so that will be right here. Okay, so now this is pointing to here, and then the similar thing will happen for the last node. So it will be, this will be changed, so I will just change it right now instead of keep coming back and forth. This will go, this will have a 3000 in there, and then this won't be pointing to this guy right here, it will be pointing to this right here. Okay, and in here, this will be 30, and then this will go to nil. Okay, this will go to nil, and once this is to nil, then if you go back to here and see that as long as it's not nil, it will be keep doing it. So it's nil, so it's not going to go to this body. Okay, and append is not really called again, basically. So it is going to go and finish up, and then it will come and print out this head dot, L dot head. So that's what you're getting this, uh, this printout right here. Okay, the first, uh, and then the data, and then the address of that node. Okay, where the data is. Similarly, second node, the data and the address of that node, and then the data and address of, so that last node is pointing to nil, so basically that's why it is nil. Okay, so you can walk through, instead of doing it this on these lines this way, the better yet, loop through the list. You can loop through the list instead of manually chaining, so you can just say, E, and then short declaration, get the head, which is this head never moves, and then you go until you hit this nil. Okay, and then going, on each one of them, and it will print this one. So this is a better way to walk through the linked list. Okay, so basically, um, uh, instead of doing the linked list manually, each node at a time like we did it in the previous example, this is a better way of writing the linked list code. So this concludes Unit 5, Chapter 4.